Welcome to solverfy.
Okay, so I have the following bond line wedge hash drawing. It's bromine on carbon 2 and bromine on carbon 3 from this point of view, both pointing towards me. And I've been asked to draw this as a Fischer projection. Well, one thing that I want to point out is that if you have, say, some Fischer projection, what this is equivalent to is looking down, say, some 4-carbon chain of molecules that are constantly twisting away from you. It's equivalent to looking down on that from the top. So if this is an eye, I'm looking down on it. All right, whatever is a wedge is going to be on the right-hand side. So if I put R for right, this would go here, and whatever is and a dash is going to be on the left-hand side. So I'll put L for left, L for left. Now this only works if my carbon chain is shaped like this. It won't work if, say, the carbon chain is shaped like this. But if I have a carbon chain that's shaped like that on the right, I can simply rotate the image of it, say by rotating around this bond till it matches this more sawhorse-like description. So what would happen if I rotated this particular bond such that instead of my methyl group pointing up and to the left, it pointed down and to the left? Like so. Okay, well, I'm rotating it 180 degrees. Okay, so the bromine would go from being in the front to being in the back. Okay, so this is the 180 degree rotation of around that bond. The bromine up here is untouched, it's still in the front. Well, now, if I think about this dynamic of what a Fischer projection represents, right, which is looking down at this molecule, down the spine of it, okay, with my eye, well, then I'm seeing that I have, is this bromine, if I'm looking at this from the spine, is the bromine going to be the right or the left? If it's on a wedge, it's going to be on the right, right? And I'm going to have a hydrogen on a dash. Now, is this bromine going to be on the right or the left? It's on a dash, so it's going to be on the left, like so. And then I'll have a hydrogen on the right, okay? So that's one way that you can convert these types of drawings into Fischer projections, okay? So now, do any of these match? Yes, in fact, this is exactly what 2 looks like, okay? All the rest of them either have some other serious problems, or like both the bromines on the same side, too many bromines, not enough bromines, not enough carbons. 2 matches identically, right? But we drew 2.